Hello AP friends. Today we're going to talk about the beginning of chapter 7, 7.1, which is really the true introduction to differential equations with definitions and some examples. So it's a pretty quick section. It's actually very straightforward. So I'll walk you through it and you'll see how easy it really is. So folks, we already talked about this before, but differential equation is basically some kind of expression or equation that consists of derivatives. That's really it. Sometimes it has other expressions or other unknown functions as well, but it's known because it has a derivative in its expression. For example, if you look down over here, this example right here is a differential equation. It's got an x cubed expression, but the most important part of that is the derivative of y or y prime. And that's what distinguishes it as a differential equation. Now the book will use this word order, but we don't use it too much on the AP, but it's kind of good to know. The order basically just sort of labels that differential equation based on what is the highest derivative in that expression. And for example, if you look at this first example, we have a derivative of y, and it's the first derivative, so this is considered the first order differential equation. If by chance we had another one that has a first derivative and also a second derivative, we would consider that a second order, because the highest derivative is the second derivative. But again, the AP doesn't care too much about that, and we won't say it too much either. But in case you see that in the textbook or anywhere else, you know what that means. So folks, do you agree that this here, if this is a differential equation here to begin with, first order, do you agree that this here could be a solution to that? And by solution, I mean, can we check that it is actually a solution by taking the derivative of it, and do we get this back out? Well, let's actually try. Let's take the derivative of this bottom function, y prime equals, power rule, we get basically x to the third, and the c turns into 0. Well, there you go. We got exactly what we started with. So, is this a solution to this? Yes, it is. So on some questions they might ask, can you check if this solution here really is a solution to the given differential equation? And all you have to do is just take the derivative and show that you get the differential equation back out. Here's another example of that. Can you show that this expression here, notice that he is not a differential equation because there's no derivatives in that expression, but can you show that that is a solution to this differential equation here? Can you figure out the order of this differential equation? If you look and see, the highest derivative that's here is a y prime, so it's just an order of 1. All right, so you want to check if this expression here is a solution to the differential equation, and what you basically do is plug it in. But do you notice that in our differential equation we do have this? So I do need to find that first. Well, if we give our solution expression here, let's find the derivative. Y prime equals 1 minus a negative x to the negative 2 power. All right, well, let's just simplify that a little bit. That's 1 plus x to the negative 2, or you can write that as a fraction too. All right, so now I feel like I have a lot of things I have to plug in over here in the differential equation. I've got x, that's good. I've got my y prime that I found, and the y here is actually the same y over here that you started with. And x is also just x. So from now on, folks, all you're going to do is just plug in everything and show that it works. Let's give it a try. See if you can beat me to it. All right, x is just x. Y prime is what we found over here, so I'll plug that in. That's 1 plus x to the negative 2 plus y is the original, x minus x to the negative 1. Does that equal, with the question mark, can we prove that that equals 2x? All right, let's just play with this left side and see what we get, folks. I get distributing, I get x plus x to the add powers plus x minus x and minus 1. Again, does this equal 2x? All right, notice what you have on the left side. I see that I have a lot of common terms here, especially these two that are gone. Those are out. And then these friends don't cancel, so I have, how many of them? I have 2 of them. So is it true? You betcha. I like these kind of problems because basically all you have to do is just plug things back into the differential equation and see if it's true. Sometimes you have to take the derivative as well and plug that in as well, but it's mostly just algebra. All right, let's do one more. This one's a little bit more of an AP type question. This one says, for what values of r, whatever r is, does the function below here satisfy this differential equation? Can you figure out the order of this differential equation? Check the highest derivative. There it is. So this is a second order. Okay, not a big deal. But again, what this question is saying is, can you show that this is a solution of this differential equation? In which case, what would r have to be equal to so that it is a solution? All right. Well, before we plug everything in, look what we're going to have to plug in. I'm going to need a second derivative. I'm going to need a first derivative. And I'm going to need y. Well, in our checklist, we have y already. That's on the left side. So we need to find the first derivative, and then we need to find the second derivative and plug everything in. All right, if you'd like to pause the video now and try it on your own, and then check back and see if we match. Okay, folks, I'm going to take this equation over here, and let's find the first derivative, y prime equals, all right, this is a chain rule. You can think of our entire exponent here as sort of a u inner function. So this would be, the derivative would be e to the rx times chain, the derivative of u, or derivative of rx, would just be the constant r, whatever that is. So it basically is just r e to the rx. Okay, I've got that. I'll plug that in a second. Now, why don't we go ahead and do y double prime? Okay, well, r is just a constant, so I'll keep them outside. And let's take the derivative of e to the rx. Well, the good news is you did that already when you found the first derivative. So I'm just going to cut and paste this guy and plug him right in inside the parentheses, because that was the original derivative of e to the rx. So the second derivative really is r and r becomes r squared e to the rx. Okay, I think I'm good to go. Now we're just going to plug everything into here and see if it really does work. And if it does work, we should be able to solve for r. Here we go. 2 y double prime was r squared e to the rx plus y prime was r e to the rx minus the original y expression was e to the rx, and set that equals 0. Okay. Well, that 2 in the front, I'll kind of clear that out. That's 2r squared e to the rx plus r e to the rx minus e to the rx. Well, I look around and I see that each term does have an e to the rx. So what could I do with that? Ooh, let's factor it out. Okay, let's take e to the rx and factor that out. What would be left on the inside? Let's see. How about 2r squared plus r minus just 1. Okay. All right, that's great. That means we can now, these factored, we can set each piece equal to 0 and solve. Well, the good thing is over here, remember we talked about e, no matter what, will never ever equal 0 because of the way the graph is. So we can completely just cross this option out. We don't have to think about it. Don't even look at it. All right, why don't we work on this one over here? This one is totally factorable. How about a 2r and an r? How about a 1 and a 1? Now let's say a minus plus. We can check and FOIL really quick, but I think my skills are lit, so I think I'll be okay. So now that means over here, r equals 1/2 or r equals -1. Now, what was the question asking? Why don't we go back and just double check? The question is saying what values, so I could get more than one, of r does this function on the left satisfy or as an answer solution to this differential equation? Well, when we plugged everything in and did all the work, it seems like my 2 answers for r that would work would be these 2. And that's my final answer. And that's your introduction basically to what differential equations are and how we're going to use them on the AP. Pretty straightforward, right? Good job today.